The next kind of pollution is something you maybe hadn't thought about before. It's called thermal pollution. It's when you raise or lower water temperatures from normal levels, and that can affect water quality and a lot of different types of aquatic life. Some organisms are adapted to certain temperature regimes, and if you change that, they might not be able to deal with it. Another important thing is that gases are dissolved in the water, and some of them are not super important, but some of them are really important. So one is oxygen, the oxygen we breathe. It's dissolved in water, and that's how fish and a bunch of other aquatic organisms get the oxygen they need to survive. And if the temperature of the water goes up, the solubility of oxygen in water goes down. So if water gets hot, there's automatically less oxygen in that water, whether you have eutrophication going on or not, like we talked about before. But so that's one way that changes in water temperature can be really important. So this just graph shows oxygen solubility in water at different temperatures. And so you can see it's much higher when it's close to freezing than when it's 35 degrees Celsius, which is really warm. We also get thermal pollution from industrial cooling processes. So a lot of factories, energy plants, things like that, they need to heat things back down. And so they'll often take river water in, cool down something in the factory, and then discharge the water. They're not necessarily adding any contaminants to it, but they're warming the water up and then putting it back in the river. And so that makes that water warmer and has less oxygen in it. And this disrupts natural ecosystems. So if there are organisms that are really sensitive to heat, they might not be able to live in that area of the river. Other organisms are attracted to warmth. And so an example of this is manatees. So some manatees in the winter like to hang out next to plants because they're discharging all this warm water. But sometimes it can be problematic if they become reliant on the warm water and then the plant shuts down this flow of warm water and the manatees don't have that available and now they're in the wrong place in the winter kind of thing. Another thing that can happen is the release of cold water from dams. So depending on where the outlet of the dam is, if it draws from the bottom of the dam, it's going to have much colder water than at the top. And this can be bad for native aquatic organisms, particularly fish. But some places take advantage of this and introduce non-native trout because you can grow trout in cold water. They really need that cold water to survive. And so by discharging this cold water, it allows people to put in trout that are often don't belong in that river, and then the trout can affect native fish. So that's an example of an indirect effect where the cold water might not be a problem for some of the organisms, but the introduction of trout, because there's cold water there, might be harmful to some of the smaller fish. A couple other types of pollution that I mentioned before: noise pollution and light pollution. Noise pollution can interfere with organisms' ability to communicate with one another. And so a classic example is marine mammals. They need their hearing to communicate long distances with each other. And sometimes sonar used by commercial and military vessels can be very, very loud underwater and can actually harm the hearing of some marine mammals, and that can be very harmful. Also, just loud background noise can make it harder for animals that communicate with sound. So think of bird calls, think of frog calls. If there's too much noise, they might not be able to live somewhere because they might not be able to communicate with one another. Light pollution is another example. Some organisms are highly attracted to light. And we can see this is a picture of the United States at night from the space station, and we can see how much light is visible from space at night. So all the street lights that don't have caps over them, they're emitting all of this light. And it can be harmful because it attracts insects, which can attract predators of insects. There's also a lot of concern about sea turtles because sea turtles use light to navigate, and the turtles can go in the wrong direction and they think they're going towards the moon reflecting off of the ocean, but they're actually going towards an apartment complex or something like that. So in some states, they actually ban white lights right on the beach. And if you're out at night, they really recommend that you use a red light because they can't detect the red light, but they can detect the white light. So you cover your flashlights or your headlamps with a red film so that you're not disturbing sea turtles and other marine life at night.